Hi, I'm Nimki Curley.
Hi, I'm Anna Martin.
One of the largest obstacles our planet faces when dealing with sustainability is the issue with plastic pollutants. More than half of all plastics ever been produced have been made since 2000, and 91% of plastics do not end up being recycled. This is mainly because it is more economical for businesses to continue production than to recycle and reuse produced plastics. Our client, Sector 67, is working to reduce our community's disposal of plastic by recycling plastics and turning them into new reusable items. Sector 67 is accomplishing this by partnering with Precious Plastics, a nonprofit whose goals are making the reusable plastic movement accessible to local communities. This process includes collecting old plastics and shredding them down to be turned into filament that can be cut into pellets and molded into new reusable items. Sector 67 has an extruder that produces the recycled plastic filament. However, it lacks a way to create plastic pellets from this filament to be used in their larger scale 3D printing and molding. Our team's assignment was to develop a die to separate the existing 1/2 inch diameter filament from the client's extruder into smaller 3 mm in diameter filaments that are then to be cut into 3 to 5 mm length pellets. In this design, the existing filament is split into smaller filaments via tubes. The filament falls into a tub of water where the shape of the tank naturally slants up and inward to guide the filament into a slot for cutting. A double-sided blade attached to a motor then moves it up and down and cuts the filament into pellets. The pellets are collected in a bin attached to the bottom of the machine. In this design, an attachment to the extruder is made to turn the filament extrusion 90 degrees. The filament is pushed out of a mold in order to split it into the proper 3 mm diameter. The split filaments are then cut as they exit the mold. This is done by a double-ended spinning blade which is attached to a motor. After the filament is cut, the pellets fall into a tank of water. Gravity helps mold them into more spherical shapes, which are then cooled in the water. Lastly, we incorporated a strainer attachment that allows for the pellets to easily be extracted from the tank of water. In this design, the existing filament is split into smaller filaments using a triangular attachment. The purpose of the triangle is to prevent the pellets from hitting each other while falling. The filament, once split up, is then cut using a windmill-like chopper. The rotations will be perfectly timed to give the pellets their proper size. The windmill will be powered using a motor and a belt to turn it. In our final design, we used a combination of all three preliminary designs. From the chopper design, we took the attachment piece, in which splits the existing filament into 3 smaller strands via tubes. The overall cutting mechanism was similar to that of the windmill design, in which a motor and belt system was used to turn a spinning blade. Lastly, we took the cooling method from the gravity design, in which the pellets would fall into a water tank after cutting.